Okay, so this is section 7.4. We're going to talk about adding, subtracting, and multiplying radicals. Next time we will pick up on dividing radicals. Okay, so we treat radicals the same way we would like treat a variable. So for example, if I was adding 3x plus 2x, all you do to add 3x plus 2x is you add the coefficients in front, right? 3 plus 2 is 5. You have 5x's then. You don't write 5x squared because we're not multiplying here. You just add the two numbers in front. It's the same idea with radicals. So if I had 3 times the square root of 5 plus 2 times the square root of 5, as long as my square roots of 5, the part that's inside the radical is exactly the same, I can just add the coefficients together. So 3 plus 2 equals 5, and it's still square roots of 5. Okay, so we only add the outside numbers. We do not add the inside numbers. You might make a note of that. Only add the outside numbers, which is the coefficients, not the inside numbers. Okay, so let's do a few examples like that. If I had 2 times the square root of 7 minus 8 times the square root of 7. We do the exact same idea with subtraction. My roots are the same, square root of 7, so I just do the numbers on the outside. What's 8 minus 2? Negative 6. And so it's negative 6 square roots of 7 is your answer. The thing here that you have to remember is the root has to be the same, the number inside the root and the actual root. Like I couldn't do a square root of 7 and a cube root of 7. It has to be the exact same thing. So if I had 5 times the cube root of 3x plus 7 times the cube root of 3x. I can add those together because they both have the cube root of 3x. I'll just add the numbers on the outside. What's 5 plus 7? 12 times the cube root of 3x. Okay. So if we had 4 times the square root of 2 plus 2 times the cube root of 2. For this one, you cannot add these together. Why can you not add these together? Yeah, because square root and cube root, you cannot put together. They're two different things. So like, that's your answer. Like there's no way to add those two together. Okay, so what about if it looks like this? The square root of 20 plus 2 times the square root of 45. Can you add those together? As they are right now, no, you cannot. But do those look like problems that you could simplify? Yeah, I could break down 20, right? 20 is 4 times 5. And that 4 is 2 times 2. So the square root of 20 is 2 times 2 times 5. I can bring out a pair of 2's here. And so it's 2 times the square root of 5. For the other one, for 45, I can break that down also. 45 is 9 times 5. 9 is 3 times 3. So this is 2 on the outside. 3 times 3 times 5. What can you bring out on this one? A pair of 3's, right? So I can pull out a pair of 3's. There's already a 2 out there. What do you think I'm going to do with the 3 and the 2? Yeah, just multiply them together. So it's going to be 6 on the outside times the square root of 5. And now can I add them together? Yeah, what's 2 square roots of 5 plus 6 square roots of 5? 2 plus 6 is 8 square roots of 5. So most of the time when you have these problems, it's going to be 2 things that you need to break down, and then they're probably going to match once you break them down. And then you can add them together. Let's do a few more like that. Let's do number 5. Let's do the cube root of 54 minus the cube root of 16. So take a second and break those down. So for 54, I got 2 times 3 times 3 times 3. We're taking out groups of 3 here because it's the cube root. In this case, I have 3 3's I can pull out and put out front. So it's going to be 3 times the cube root of 2. For 16, I have the cube root of 4 2's. What can I take out of that one? Yeah, 3 2's. So this is minus 2 times the cube root of 2. And now that they match, I can put them together. What's 3 cube root of 2 minus 2 cube root of 2? 1 cube root of 2. So you could write it as 1 cube root of 2, or you could just write it as the cube root of 2, either one. Questions about that? Let's do one more. If I had the cube root of 24 minus 4 times the cube root of 81 plus 3 cube roots of 3. Count each one of those. So 24 would be 2 times 2 times 2 times 3. I'm gonna go do that one. Whenever I pull out 3 2's, I get 2 times the cube root of 3. For the next one, for 81, it's 4 times the cube root of 81. 81 is 4 3s multiplied together. And take out a group of 3 3s. And when I put it out front, I need to multiply it with that 4. So it's going to be minus 12 times the cube root of 3. And then this last one, 3 times the cube root of 3. Can I break that down at all? No, and it already matches this. So that also tells me I don't need to break it down anymore. Plus 3 times the cube root of 3. And now I can add all this together. What is 2 minus 12 plus 3? Negative 7. So I get negative 7 cube root of 3. Questions about that? Okay, let's do that's adding and subtracting. Like that's as hard as it gets right there. Is if you have to break down multiple problems, you just break them down and then add them together once they have the same number. Usually, I mean, for sure, any problem I give you is all going to match up at the end. Math Excel may have like 1 or 2 that doesn't match up. Just make sure you know, like, not to combine it. But usually, if they don't end up matching up, you might want to go back and check your work and make sure you broke it down right and took everything out right. Okay, so let's move on to multiplying. So that was adding and subtracting. Now multiplying. So the rule for multiplying is you multiply outside numbers with outside numbers, and you multiply inside numbers with inside numbers. Okay, so you do outside times outside and inside times inside. You never multiply an outside number with an inside number, or you don't like distribute an outside number with an inside number. For example, let's do just some like 1-term problems, and then we'll get into the whole like multiplying, like foiling it out, and that sort of idea. So if I had the square root of 3 times the square root of 2. 3 is an inside number, 2 is an inside number, so you do 3 times 2, and you get square root of 6, right? But if I had 2 square roots of 3 times the square root of 2, I would still multiply my inside numbers, the 3 times 2 to get 6, and that 2 is just 2 out front. Or another way you can think about it, technically, what's the number on the outside of the square root of 2? A 1, if you want to think about multiplying 2 times 1. So it would be 2 square roots of 6. Does that make sense? If it was 3 times the square root of 5, can I multiply the 3 and 5 together to get 15? No, it's just 3 square roots of 5. If we had 2 square roots of 2 times 3 square roots of 3, multiply the outside 2 and the outside 3, and you get 6. Multiply the inside 2 and the inside 3, and you get square root of 6. You get the idea? Okay, just make sure you're always doing outside numbers with outside numbers and inside numbers with inside numbers. Okay, so let's do some of these problems. Number 7. If we had square root of 2 times the square root of 3 minus 5. Okay, so we need to distribute the square root of 2 to the square root of 3 and the 5. So what is the square root of 2 times the square root of 3? Square root of 6 minus what's square root of 2 times 5? 5 is an outside number, 2 is an inside number, right? So you can't multiply those together. So 5 stays on the outside, square root of 2 stays on the inside. Okay, usually at this point we combine like terms. Do I have any like terms to combine? No, because these are 2 different roots. Square root of 6 and square root of 2 I cannot put together. If I broke down 6, I would just get 3 times 2. Do I have anything I can pull out? No. So this is your answer. 90% of the time, there's not much to do at this point. Okay. Every once in a while, you can add things together, but usually that's your answer once you get to this point. You'll see the problems when you're able to add things together. We'll do a few of those. Okay, let's do another one. What about if it was 2 square roots of 3 times the square root of 5 plus 3 square roots of 7? So distribute 2 square roots of 3 to both of those terms. 2 square roots of 3 times the square root of 5. I'm going to multiply the 3 and the 5 together because those are both inside numbers. So 2 stays on the outside, and I get the square root of 15. And then 2 square roots of 3 times 3 square roots of 7. I do 2 times 3. Those are the outside numbers to get 6. The square root of 3 times the square root of 7 is the square root of 21. Are those like terms to combine? No. If I break them down, is there anything to take out? No, that's just 3 times 5. That's just 3 times 7. So that is my answer. What about if I had 7 square roots of 5 plus 2 times 3 square roots of 5 minus the square root of 3? So this is one that I need to FOIL, or like double distribute the idea. So I need to multiply 7 square roots of 5 times everything in the other parenthesis. So 7 square roots of 5 times 3 square roots of 5 is 21 times the square root of 25. 7 square roots of 5 times negative square root of 3 is negative 7 square roots of 15. Now I'm going to distribute this 2 to everything in the other parenthesis. So 2 times 3 square roots of 5 is 6 square roots of 5. And 2 times the negative square root of 3 is minus 2 square roots of 3. Are we good with that? Okay, from there, we look to see, is there anything we can simplify? Can we combine any like terms? Look at the first term, 21 square roots of 25. Can I do anything with that? Yeah, what is the square root of 25? 5. So that's like 21 times 5, right? And 21 times 5 is 105. Because I took the square root of 25 to get 5. And that says 21 times the square root of 25. So it's 21 times 5, which is 105. Look at the rest of it. Square root of 15. Can I break it down? Take anything out? No. Square root of 5. Can I break it down? Square root of 3. Can I break it down? Can I combine any of those? So just write it all after that. Minus 7 square roots of 15 plus 6 square roots of 5 minus 2 square roots of 3. Questions about that? Okay, look at this problem. If I had 2 square roots of 3 plus the square root of 5 times 2 square roots of 3 minus the square root of 5. We're going to distribute that one just like we did the last one. Two square roots of 3 times 2 square roots of 3 is 4 square roots of 9. 2 square roots of 3 times negative square root of 5 is minus 2 square roots of 15. Positive square root of 5 times 2 square roots of 3. It's plus 2 square roots of 15. And positive square root of 5 times negative square root of 5. Minus the square root of 25. Okay, let's look at each piece. 4 times the square root of 9. Yeah, square root of 9 is 3, so this is 4 times 3, which is 12. For negative 2 square roots of 15, can I break it down, take anything out? Can I combine that with anything else? Yeah, isn't there another square root of 15 right here? What is negative 2 plus 2? 0. Right? So that's like 12 plus 0. Over here, minus the square root of 25. That's 5, right? So this is minus 5. So 12 plus 0 minus 5. What's 12 plus 0 minus 5? 7. That one was totally different than any other problem we did, right? Because it came out as a nice, pretty answer, okay? It got rid of all the radicals. They all went away, and we ended up with a nice whole number. That's because, look at your original problem. What do you recognize about this original problem? It's essentially the difference of 2 squares, right? The first term is the same. The last term is the same. One's a plus, one's a minus, okay? This is called the conjugate. Okay, a conjugate is the same thing, but the different sign. So if I had A plus B, the conjugate would be A minus B. Or if I had A minus B, the conjugate would be A plus B. Okay. The whole reason of using a conjugate is the conjugate gets rid of ugly stuff, essentially. Okay. Didn't I start off with ugly stuff in this problem, all these radicals? And look how nice it got. Like I got rid of all the radicals. Okay. So next time we are going to use the conjugate to get rid of radicals. That's our whole goal next time is when we're dividing, we're not allowed to have radicals in the denominator. So we're going to get rid of them by using the conjugate. You can also use this conjugate with the I. If you had i's in a problem and you wanted to get rid of the i's, you can multiply by the conjugate and get rid of all the i's in a problem. And instead of being an imaginary number, it would turn it into a real number. I think we actually did one of those on the day we were multiplying, but I didn't really address it then. Okay, so we are going to pick this up next time with the conjugate. We're going to use this to divide radicals. So make sure that you know how to add, subtract, and multiply. Adding and subtracting is just combining like terms. Multiplying is just multiplying and then combining like terms. And on Friday, we will pick up with that and talk about rationalizing the denominator.